Hello everyone, welcome to the Emerging Pod, where we guide emerging people into emerging careers. Today's guest is Heiko Hotz. Heiko has an extensive career that spans software development, consulting, and data science, which took him from Munich to Zurich and now London. He started off at Panasonic before moving on to Cuperia, FTI Consulting, and most recently Amazon, where he's a senior solutions architect for AI and machine learning. Finally, in his spare time, he does some consulting on the side and organizes the AWS NLP Summit, as well as the London NLP Meetup. Great to have you with us, Heiko.
Thanks for having me.
Thank you for joining. So let's kind of dig straight into it. So you went to the University of Munich and you chose to study physics and computer science.
That's right.
What inspired that choice? What made you do that?
It's a good question, actually. I actually started with computer science as a major because I already knew how to program when I went to university. I started programming when I was around 14 or 15. So for me, the logical choice was to go to university and study computer science. And then I found it really dull, to be honest. Well, not dull is not the right word, but it just wasn't what I expected. It was a lot of more math than I expected. I was like, oh, I'm going to go to computer science classes and I'm going to learn how to be a really good programmer. And, in retrospect, if I understand why you need to learn mathematics to be a really good programmer, but that wasn't exactly what I was looking for. And I had physics as a minor, and I found those classes much more interesting. So I was like, after a year, I was like, why don't I just reverse that? So I studied physics as a major, theoretical physics, and computational physics, and I had computer science still as a minor. And that was a perfect combination for me, because in computational physics, you need to have a little bit more of a hacker mindset. And by hacker, I don't mean like a nefarious person who hacks into systems, but more like you don't need to know the math really behind the programming that you do. You just need to get something up and working. And that was more the style. So to this day, I wouldn't say I'm a good programmer because I'm not really interested in all the math and optimization behind it, but I can, quickly stitch some stuff together and get it working.
You mentioned that you've learned how to code before you actually went to university, and that's kind of a trend that we see with a lot of people. How did you learn how to code, and what languages did you use?
The first language I used was BASIC. So I don't know if people even know that language anymore, but it's not a basic language. It's a language called BASIC. And it's a good way to get started, especially at a young age, because it follows, like if you start doing object-oriented programming, that's something that is not quite the way our like logic in our brain works. It's more like our logic in our brain has if then, and then if this, then jump to that. And that's what you can do with BASIC. But once you start getting a bit more sophisticated with BASIC, then it becomes what it's called like spaghetti code, because it just, in BASIC, you just have these jump points. So if this, then jump to this point, and then if this, jump back to this point. So at some point, I reached my, the things I can do with BASIC reached a ceiling. So I then just asked my uncle, who introduced me to programming in the first place. I was like, is there something, out there that is better suited for more complicated programs? And he introduced me to a programming language called C. So I used C for to basically move on from there. I used it then during high school, where we had a computer science class. I used C there. And then in the first job at Panasonic, I also programmed in C++, actually. And then in university to do my major thesis, that was also in C++. I stuck with that actually for quite a long time, yeah.
Oh, interesting. Do you remember the project you were doing in Basic where you reached the limit? And have you tried then to do that project in C?
Yeah, it was, I think, around the time when I started doing like a database for my CD collection, where I got
Nice.
like, it was like super basic, right? But, you know, if you're like 15, 16 years old, it's quite cool. Or when I started doing like very simple games like Hangman. Yeah, so that's, I think, where the transition started, where it was like my code in Basic just became so long and really not manageable anymore when I tried to do a database for my CD. So that's when I then basically made the switch. And then I think the Hangman game, where you have to guess letters in a word, that one I already didn't even try in Basic. I think that's I did that completely in C.
Okay, and then moving on to, I suppose, the first job at Panasonic. How did you get
Mm.
that? How was that transition from education into employment for you?
So Panasonic was actually during my studies, so it was in parallel. I worked there during the breaks. So in total, I worked between 5 to 6 months at Panasonic. During the semester once a week, and then in the breaks in between, in the summer and winter break, I worked there full time. So in total, probably around 5 to 6 months. And again, I got that through my uncle who worked there, and he was like, you know, being a student in Munich was quite expensive. And he was like, "Yeah, you want to earn some extra money on the side." And obviously, he knew already that I could program, so I started out there as a tester, actually, or not a tester, but a a software engineer that write test programs. So it's like unit testing, and just, you know, test programs for the compiler that Panasonic developed. So Panasonic developed a compiler and an IDE for programmable controller units, PCUs. Basically, if you think about your garage door opener, right? If you press a button, the garage door opens. But how does it know to do that? Well, you have to program it. And in order to program it, you can use one of those IDEs that Panasonic develops. And those IDEs are again written then in the back end in C++. And those IDEs compile code, proprietary code written in these IDEs. And I needed to make sure that the compiled code does exactly what it needs to do. So I wrote test programs where I was like, every time we changed something, the main developer for the compiler changed something on the compiler, we needed to make sure that all the basic functions still work. So the idea is you have a range of test programs that you run every time you change something on the compiler to make sure that it still works for all the old use cases. So that's how I got started. And then over time, I got to work a little bit more on the actual IDE development as well. So what I managed to implement, for example, is syntax coloring into the IDE. So nowadays, I mean, that's obviously a given. If you have an IDE and you program into it, you know, keywords are highlighted in a certain color versus strings versus comments. And that was already back then the case for most the prominent coding languages like C++. But in our IDE, the IDE that Panasonic developed, that wasn't the case back then. So that's something I was able to implement into that IDE, so that you would have syntax coloring.
Okay, and then you switched. You moved to Cuperior, which is a consultancy based out of also Munich, but then you kind of got to move around and live in Zurich for a little bit.
Yeah. So
how was that?
That was right after university. So after university, I was like, well, the job at Panasonic was amazing and I learned a lot, but I wanted, to branch out a little bit more into consulting world. And the idea there was twofold, really. Based on my experience from Panasonic, and also based on the experience I had during studying physics, and the diploma thesis in physics back then took 1 year to write. That was the usual time frame. So I studied 1 year in the same topic very intensely. And I also worked always on the same stuff at Panasonic. And I was like, I'm more of a person who loves to, dig deep into something for a little while, but then move on to something else, to have a little bit more variety. So that's how I thought consulting would, be quite useful for me. And that's why and how I then reached out to different consulting firms, IT consulting firms in particular, back in the day.
What was an interesting project you worked on during that time?
During that time, I guess one of the most interesting projects I worked on was a project where we had PDFs that are editable. So there's this public organization in Zurich, and their workflow was they would send out PDFs to citizens, and usually these PDFs would be read-only. And then in order to collect the data, they would have to use some sort of HTML form, like a website or something. But, it wasn't possible back then for the organization to send out to the citizens a PDF, and the citizens just fill in the PDF and write that data into a database. So that's a project I worked on, which I found quite interesting because it was very new technology back then. It was basically having a PDF where you can actually write in your answers and send that back via email, and then the email comes in, and then I created this workflow where the attachment from the email, which was that PDF where the answers were recorded, would be extracted, and then take the answers from the PDF automatically and write the data into a database.
Nice, a little bit of data engineering on that side.
Yes.
So was that one of your first forays into the world of data?
Yeah, you could say that. Like a lot of projects back then were actually in the database realm, because the IT consulting firm Cuperia I worked with, they were specializing in SAP, the Enterprise Resource Planning System. I don't know if you've heard of it, but basically it's a system where you basically manage all your business processes. And so a lot of the projects I worked on back then were around, how do we store data? Like what is master data and what is application data? How are they different? How do we store them differently? I learned a lot about databases and SQL back then, which I didn't have really a lot of knowledge before that job. So, and SQL is probably one of the most important languages still, I think, out there. So I was very grateful for that experience.
And what made you want to move to London?
So London was actually I wanted to do an MBA. So during my time, I always had something to do with technology or science. So I have a science background, obviously, with physics, and then I worked in an IT consulting firm. But as a consultant, I obviously more often than not also get in touch with the business people in the companies I worked for as a consultant. So, I'm a consultant, I'm going to my client, and usually I would have to do something with IT consulting, but sometimes we also meet the business people. And I I realized I didn't have a lot of understanding of like the business aspects of the stuff we were doing. So I thought it would be a really nice complementary skill if I could rack up my business acumen. And, you know, after researching a little bit, I thought an MBA would be a good way to do that.
And how did that open up further career opportunities? Was that when you then joined FTI?
Yeah, so I basically came to London. So I studied then the MBA at London Business School from 2013 to 2015. And during that time, we are encouraged during the summer break, so in 2014, to do an internship. And I managed to get an internship at FTI Consulting, which was still in a technical part of the consulting firm, but it was much more business oriented as well. So the internship I did in the analytics team at FTI Consulting, and what they usually do is they look at financial fraud cases, do forensic litigation. So if you, for example, imagine, there's a financial fraud case, one party is accusing the other party of financial fraud. There's obviously a lot of transactional data, and that needs to be analyzed in order to give the lawyers some information in order to, so that the lawyers can make their case. So that's the internship I did in 2014, and apparently I did an okay job because they offered me a full-time offer after my MBA. So that's when I then, in 2015, after my MBA, started at FTI Consulting as a senior director.
That's really interesting. At that point, were you aware of the kind of growing field of data science and data science as a career in itself? And did you know that you were attracted to that?
Yeah, not at the point when I started at FTI Consulting, but because now I was a little bit more removed from the database part and the data management part and more into analytics. I started obviously then seeing, analytics. If you look at it from a way that analytics is basically looking at past data and trying to get insights from what happened in the past, there is naturally another side to it, which is the looking into the future part, which is using patterns from the past in order to predict the future, which is where data science came in. So after a few months of being in the analytics team, I started realizing, there's another side to this, which is looking into the future. So I started doing like online courses. I started learning about data science, about machine learning. At that point, I also had switched my main programming language to Python, which is a little bit more modern, obviously. So that enabled me to quite easily follow these classes, these online classes that I did on machine learning and data science.
Oh, interesting. And you mentioned you worked in some, you were working on financial crime. What's the most interesting project you've worked on? And I guess coming from a technical space, how did you approach, getting into the finance space and understanding it?
Yeah, I mean, in the end, for me it didn't really matter. Like, it's data, right? Whether it's financial data or some sort of operational data. For me, it didn't matter. At least not when it came to the most interesting project I worked on during FTI Consulting, which was a really large financial fraud case. I think it is the largest and longest financial fraud case that was ever litigated at the Cayman Islands. So if you look for like longest fraud case in Cayman Islands, and there should be something coming up around a company called AHAB, AHAB. I might be able to find a link to and send it to you afterwards as well. But basically what we did there is there was this company called AHAB, and they accused another person of embezzlement. They accused this person of embezzlement of, I think, $9 billion US.
Whoa.
And to spoil the ending right away before I get into the actual project, we managed like our side. I was working for lawyers who were working for the defendant, and they were actually able to not only disprove the allegations of embezzlement, but they also during the litigation, during the process, it found out this company Ahab actually they did some financial fraud. They were complicit, I have it here, in a $330 billion Ponzi scheme between the period of 1980 to 2008. So, a large amount of money that is thrown around here. And what I did in order to help the lawyers to disprove the allegations is I built a tracing tool, which is it wasn't straightforward, to be honest, because what the question that the lawyers had to answer is there's a bank account in 2008 that belongs to our defendant, and there's money in it. Like, what does this money consist of? Is there any tainted money in that account? And then I had, a list of transactions. I think it was like around 1.4 million transactions that needed to be analyzed. And every transaction, it's not only the 1.4 million transactions, because imagine this: if I have a bank account with £20 in it, and you stole some money of £50 and put that into my bank account, now I have £70 in my bank account, and now I send £40 to a friend of mine. Like, these £40, how much of that, from a legal point of view, is tainted money, right? I had $20 clean money in it. You gave me $50 of dirty money. I send out $40, and now I have to suddenly split this one transaction of $40 into two. One where it says $20 were clean because it was my own money, and $20 were tainted because it consisted of the money that you sent me. So one transaction now splits into two transactions, and you have to keep track of all those transactions and the splits within those transactions to be able to say at the end, the 1.3 million that are in this bank account of my defendant, it came from this bank accounts, all flowing in together, intermingling with each other. So it's a very difficult question that these lawyers have to answer. I actually found the article as well, so I'm gonna send you this one here. It's a very difficult question that these lawyers have to answer. And usually the way they used to do it is going manually through Excel sheets, and that takes months, if not years, usually. So I basically built a tool in Python, quite straightforward, that actually that automated this search, this keeping track of these splits within transactions, and being able to just type in an account number, the funds in that account, and then it would trace back all the way to the sources of that money. So the lawyers would be able to say, okay, the 1.3 million in our defendant's bank account, it came from these sources, and none of that was actually tainted money. So our defendant is clean.
Wow, that's really interesting. I can't imagine how much you've had to learn in such a short amount of time to be able to do it. But I guess go for it.
No, it was great because I actually managed to also leverage some of the knowledge I learned during Panasonic when I wrote test use cases, because I had several tries to set up this tool, this algorithm. And in the beginning, it failed. quite a few times, and so I iterated on it. But when I iterated on it, it would work for certain edge cases now, but it would fail for other edge cases. So what I did is actually I wrote test use cases, and every time I changed the algorithm, I made sure it worked for all the other edge cases I tested it before.
Nice, nice. And so how did you then transition from FTI and the financial world into Amazon?
Yeah, so as I mentioned, during my spare time, I already was more interested in data science, and I saw that tech companies like Amazon would in the long run be a more interesting place for me if I wanted to really get into data science. So during that time, I also started working as a volunteer for an organization here in London called DataKind UK. And what DataKind does is imagine you're like a data scientist or someone who aspires to be a data scientist like I was back then. And there are a lot of charities around London that collect actually a lot of data, but don't have the skills or the knowledge or the time or the money to leverage data science for the data that they are collecting. So DataKind UK is a platform or an organization that allows me as a data scientist to donate my time and my skills to projects to work with other charities. So DataKind brings them all together, the charities and the volunteer data scientists. And then what we would do is like maybe a weekend hackathon with those charities to dig a little bit deeper into their data, and also do longer projects with those charities. That is all to say, that's how I got started with data science. And I then realized at some point maybe a move to Amazon would be quite good in order to also ramp up my data science skills. So I started out in the supply chain team as a technical program manager, where I still leverage my analytics skills, because in supply chain, you're often interested in like what happened last week. Did we make our deliveries on time? Did we stock our warehouses in the right ways? But also you wanted to be looking forward, obviously. So one of the projects I worked on was a forecasting project where in Amazon, if we provision labor for a warehouse, so usually we have short contract workers working in these warehouses. So let's say next week, we estimate we're going to ship 7 million SKUs from a particular warehouse. How are those 7 million SKUs distributed over the week? How many people do we need on Wednesday, Thursday, Friday, and so on? If we overestimate how many we need on each day, then we pay obviously for too much labor. If we underestimate it, then we're short on labor and we have to do like an emergency call to call in labor on a very short notice period, which is also more expensive. So it's quite important to get it right. And as such, I managed to improve our forecasting methodology with like state-of-the-art, back then anyway, state-of-the-art forecasting algorithms like ARIMA and Prophet, instead of using the old methodologies that we used back then.
Interesting. And at the time where you arrived, how mature was data science at Amazon? Were you at the point where teams were pretty well structured and you were hiring juniors, or was it still at the point where people needed to have some level of experience in industry before joining the team?
That's a good question. I mean, it's hard to say really, because Amazon, as you imagine, is such a big company. Yeah. So there were teams, especially in Seattle, who were full of data scientists, and they did some of the most sophisticated systems I had ever seen back then. My team, the supply chain team, I was the only person with a data science / data analytics background. But it was already at the point, I think, at Amazon where Jeff Bezos, the CEO back at the time, basically asked of every team, or at least every sub-organization in Amazon, how they how they leverage machine learning in their teams. So there was, at some point, Bezos basically reached out to all the teams and said, I want every team in Amazon to leverage machine learning in some form or another. So I feel like it was just, at that cusp of changing between a structure within the organization where you had data science teams on the one hand, and then teams who had nothing to do with data science on the other hand, and going into a future where basically every team needed to have, a data scientist, or at least, some projects around machine learning.
And so at the stage you are now, are you recruiting junior data scientists? And if so, what do you look for in those early career data scientists?
Yeah. So, the position I'm in is slightly different. So first of all, I changed from Amazon to Amazon Web Services, which is a different legal entity. So at AWS, we also obviously do have data scientists, but as a solutions architect, I'm a little bit removed from the data science part and more in the solutions part of AI and machine learning. So I would say we do hire in our team, but as a solutions architect, if you want to do pure data science, then a solutions architect is probably not the right place for you. As a solutions architect, you also need to have some traits of machine learning engineering, ML ops, machine learning operations, and just being able to stitch together different solutions to help customers.
Makes sense. And I guess that's still a skill. That's still like an area where ideally the person that's recommending those systems needs to have some understanding of what data science look like. So it could be for someone that's starting in data science field, this could be a path they could explore.
Yeah. So think of it this way, really. Like my customers are data scientists. So, at AWS, we have a machine learning platform which is used by our customers and usually by the data science teams of our customers. So it's very good for me to know the in and outs of data science, like what are their needs. But my job is really for them to be successful on our machine learning platform. So I need to anticipate and listen to our customers. What are their needs? How can data scientists nowadays, for example, leverage something like large language models or stable diffusion like AI art generation? I know that data scientists want to do that, but how can they do that on our platform? And how can do that efficiently and effectively on our platform? So that's basically the role I'm filling, is trying to, point out best practices on how to leverage our platform and create demos so that customers can see how it can be done and follow my examples.
Interesting. And actually that's a perfect transition in terms of talking about large language models. It might be a bit of a very broad question, but from your perspective, can you just briefly describe what are large language models and how do you think they will change the nature of work?
Yeah, so a phrase I like to use always is large language models are like auto text generation on steroids. So, or like what? No, it's not auto text generation. Autocomplete. Autocomplete is what it's called, right? On your phone, if you type something in, it tries to complete or predict the next word. So that's basically what large language models really are. So, to back up a little, a large language model is a neural network. So that means it leverages the technology of deep learning. And it's been just, the two things that stand out with large language models compared to other neural networks is they're huge, state of the art large language models like GPT-3, they have usually around hundreds of billions of parameters. And they've been trained on a very large data set. That's the second differentiating factor. So basically, think of a large language model as a really clever neural network that's been trained on all the text on the internet. I mean, technically, that's not quite true, but, in order to, very, very simply put it, it's been trained on all the languages on all the internet. So it basically has a very good understanding of language, but at its core, it's still only a next word prediction neural network. So it tries to predict the next word, and that's how it generates these sentences and paragraphs. But it's just so much better than your autocomplete on your phone.
Ultimately, it is a statistical function, right? It just predicts what's going to be typed next based on what's been previously typed. It doesn't really have a semantic understanding of what it's actually saying, which is one of the reasons why it's such a confident bullshitter in many instances.
Yes. And you need to know that in order to make use of it, right? So I see on Twitter and, social media platforms, I see all these cases where people say like, oh, GPT-3, it's just a hoax. You can't really use it because it predicts, it tells me to, I don't know, 2 + 2 is 5, or if I ask it what did I see recently? Tell me the benefits about eating broken glass or something like that. And I'm like, yeah. I mean, it's very easy to fool these tools, but then just don't use it as medical advice, right? Use it in a way that they are built for. It's like eating a soup with a knife. I feel like sometimes people are like, oh, it doesn't work. The knife doesn't work. So, I can't eat my soup with it. Like, it's useless. No, it's not useless. If you use it for the right tasks, it's very useful. These models, large language models like ChatGPT, GPT-3, they're very useful if you want to get started with, let's say you're a writer. Oftentimes I write blog posts on LinkedIn, and I'm like, I have some bullet points in mind that I want to highlight in my paragraph, but sometimes I get writer's block. And then I just try out ChatGPT, and it gives me some ideas on how I can get started with my actual writing. Another example is these language models do very well with code. And it's almost like, so I did this with ChatGPT recently. I actually published an article on Towards Data Science about it, where I used ChatGPT to write a complete application on AWS. And it's like having a junior developer by your side at all times. Sometimes what ChatGPT produces is not quite correct, but that also happens sometimes with junior developers, right? So I can ask ChatGPT to do something, but I should not expect it to be automated because there can be mistakes in its answers. But usually the answers are very, very useful, and I only needed to change 1 or 2 things in the code that it generated, which I would sometimes have to do as a senior developer as well, right? If I have a junior developer, they send something via email. I'm like, really good. There was 1, 2 mistakes in there. I fixed it, and now we can deploy the application. Exactly like that. So all this is to say, find the use cases where these language models are really useful for, and don't think about it too much in terms of like, oh, how can I make this large language model fail? It's very easy if you want to try to make it fail. But again, I'm coming back to this analogy, eating your soup with a knife.
I think one of the things that people don't realize is the exponential growth potential of these models, and the fact that ChatGPT has been released out in the public. So all of this is training material for it. So it's learning and improving as we go along. Do you have any insights on on GPT-4, and what kind of improvements can we expect, and to what extent can that impact how we do our work?
I don't really have any unique insights. So if you have been reading, all the rumors that been floating around on Twitter, that's basically my knowledge as well. So apparently, it's going to be massive in terms of like number of parameters. The number I've been seeing floating around the most is 10 billion, which is just mind blowing. It's similar to the jump we had from GPT-2 to GPT-3. It's just unfathomable. And then the other rumor I heard is it's going to be coming out soon-ish, definitely this year, maybe even Q1 this year. In terms of what you will be able to do, I only heard, again, just hearsay, but apparently there are some people on Twitter who had early access to it and were mind blown. So, I mean, it's only going to get better anyway, right? Like that shouldn't be surprising. Like it's going to be surprising maybe to the amount of how GPT-4 is better than GPT-3. But the fact that it is all getting better and better, that shouldn't surprise anyone. So at some point, we will have to think about the impact of these language models. Right now, I still would say the impact is not like I'm talking economic and societal impacts. I mean, there's impact already on a technology level, like very large impact. But from a societal point of view, I still would say, those are tools right now, and if we use them in the right way, it makes our lives easier. But it cannot, automate my work, for example, and not at this point in time. But with the pace of improvements, we will have to think about, just think about what happened in the last 2 years, and now think about what's going to be happening in the next 10 years. I mean, at some point, we will get to a point where a large language model or maybe another AI model or another architecture will be at a point where it can automate like 95% of the work I'm doing. It can, to give you an idea of what I'm doing, customers reach out with a problem. I try to help them. I answer emails. I create demos for them. I create best practices, examples for them. All that is, it's all text-based, really. So I wouldn't be surprised if, at some point in time, on an infinite time scale, there will be a model out there that can do all that for me.
Yeah, and I think one aspect also that even just GPT-3 and GPT-4 as they will be is the fact that people can fine-tune them is something that can also be underestimated. I think from my perspective, it's probably one of the most powerful part of it, where you can take something like GPT-3 and really focus on a specific area or on a specific task and make it way better at being able to, for example, you mentioned the medical space. Maybe that could be an area that can be fine-tuned for it. I saw on your blog you posted a project on a strategy bot you developed a strategy bot for an NGO using GPT-3. Can you tell us a bit more about that?
Yeah, so this NGO, it's called Ashoka, and they are a platform for social entrepreneurs. So entrepreneurs who create social enterprises, they want to do good in the world. And in order to be admitted to that platform and communicate their ideas, they're encouraged to write strategy papers of this is my idea, this is the project I want to set up. And beyond that, even what is going to be the impact, the indirect impact I will have with my project, like what is the strategical impact, if you will. And for a lot of those social entrepreneurs, that can be quite challenging, quite daunting. It's a really long abstract that needs to be written with like complex ideas in that. And the idea of Ashoka when they reached out was like, can we leverage GPT-3 again as a starting point, not as a fully automation of writing the strategy paper, but, giving the social entrepreneurs, let GPT-3 write one of those strategy papers, and let that be the starting point for those entrepreneurs, in order to give them ideas of how they could write it, maybe even ideas on like what other strategies they could pursue in their project. So what we did is exactly what you said, Sofiana. It's we fine-tuned the GPT-3 model with strategy papers that Ashoka had from social entrepreneurs in the past. And we basically taught it, look, this is the format and the type of complexity social entrepreneurs write their strategy papers in. We gave those to GPT-3 and be like, look at these strategy papers. This is how we want you to write strategy papers in going forward if we type this specific prompt into the text box. And it turned out to be really powerful and impactful. So we trained it on only a few hundred of those examples. The training it cost about $10 in total with, a few iterations. Took only a few hours, 2 to 3 hours. And then the new model was ready and we tried it out and it was really, really good. So these kind of things I'm going to expect to get even better with GPT-4, but already, I mean, Alex, you mentioned, and I agree, these models don't have any semantic understanding of like what they're writing, but it seems like that. And I think they will become even better at pretending to the end that it's, it doesn't really matter for me anyway whether these models are sentient or not. That's not an interesting question to me. But if they are so good at pretending to understand the semantics and the meaning of what they write, does it become useful for us? And when we get to that point, and I think we're already there halfway, then, that's already something, right?
100%. 100%. And so final question is, as we see large language models and generative AI more generally increase its footprint and its usefulness, what would you recommend young people that are just transitioning into the world of work who might be learning things that could become fairly redundant in the short term? What would you recommend they do? How should they think about their transition? What should they learn?
Yeah.
What would that mindset be like?
It's exactly that danger, Alex, that you mentioned. It's like, well, if I recommend something now and then 2 years later it turns out, oh, yeah, that's obsolete now. I guess to trying to be a little bit more meta is then learn how machines think in general and learn to live with change. I know these are like very big ideas, but and not very concrete. But I think going forward, that is the way to go. If you're interested in these kind of things, try to understand like how AI works, not in a very specific way in terms of like, oh, you got to learn logistic regression or something like that, but more of the concept of like, how does training an AI look like? Think about, forward passes, back propagation, these kind of high level concepts. I don't think those will go away anytime soon. Back propagation is the essential key to how machines learn from their mistakes, how we teach them, and having a good understanding of that on a high level basis is going to be worth a lot. And then just be comfortable with change in terms of like, yes, you might be learning something that might be obsolete in 2 years, but it's not only the content that you learn, it's all about you learning how to learn, if that makes sense. So like, how do I approach a complicated subject? How do I dive deep into it? How do I find quickly the right GitHub repositories and resources in order to, when something new comes up, like Stable Diffusion, to learn that quickly as well. So Stable Diffusion for me was quite quick to learn because I studied large language models before that, and there are similar concepts that I could easily translate in order to learn how Stable Diffusion works.
Nice. Thanks, Heiko. That's some very useful and sound advice. Do you have, before we wrap up, do you have anything you'd like to promote, or where can people reach you?
So I guess LinkedIn is probably the best site to reach out to me. So my LinkedIn profile, Heiko Hotz, if you search for that, I should be the only one coming up, maybe not, but put AI and machine learning behind that, then you should be able to find me. Also, if you're in London, if you live in London, I organize regular NLP London meetups. They're only in person only, so no way to attend virtually. So if people want to come to those, it's free usually, and there's going to be food and interesting crowd. You can exchange ideas. What else? Yes. DataKind, reach out to DataKind if you're interested in, if you're an aspiring data scientist and want to hone your skills a little bit. DataKind, I think, is a great platform as well. And then, that should be it. I mean, I'm looking forward to anyone who, at some point reaches out because they listen to this podcast. That'd be amazing.
Thanks for your time, Heiko.
Thanks for having me.
Yeah, this was awesome. Thank you. We'll put all the details and links to the fraud case and everything else you mentioned in the show notes.
Perfect. Thank you so much.
Brilliant. Thanks for your time, Heiko.
Cheers. Thanks. Bye.
Bye-bye.